I'm Greg Gershuni. I'm going to be moderating the session today. Cows, corn, and CRISPR, understanding biotech's promise for climate solutions. And so we're going to talk over the last day and until tomorrow. We're looking at a number of different solutions for climate change, both to reduce emissions, to build resilience, to build products, and other things that currently use things that emit carbon or using carbon for those solutions. And so this is one of the most exciting, but also newest kind of areas that we're looking at as a climate solution. And so I think this, for a lot of people in the room, this is going to be relatively new. And so I kind of want to start at the top and think about what is biotech and how can it play a role in climate solutions. So, David, can you introduce yourself and talk about biotech and how it's evolved over the last few years to kind of where we are now?
Sure. Hi, I'm David Babson. I'm the Executive Vice President for Climate and Energy at XPRIZE. It's actually my second day on the job at XPRIZE.
Go, David.
So,
Not every day in X Prize is in Miami Beach, I think.
that's right. I know. But my background is in chemical engineering, and I've worked a lot at the interface of the bioeconomy and climate solutions and energy for a long time, and the biotechnology field, particularly as it pertains to the bioeconomy and climate solutions, has been slower on the uptake as compared to pharmaceutical applications. But there are a number of opportunities in synthetic biology, the new capacities for CRISPR and gene editing and biological engineering that are allowing us to look at the multitude of systems that leverage natural processes like the agricultural system to apply biotechnologies to make these systems more efficient or capable of providing new types of services, like in the case of agriculture, new services in ecosystem services, carbon drawdown, and greater resource efficiency. And so, the advances in biotechnology are allowing us to kind of rethink those systems and re-engineer them to be more efficient and more aligned with a future that is climate conscious.
Excellent, thank you. Now, Brad, you run a lab and you work on CRISPR-Cas9. Talk about you and who you are and what you're doing and what is CRISPR?
Yeah, thanks again for having me here today. So I'm the executive director of the Innovative Genomics Institute that's on the campus of UC Berkeley, and we were founded by Nobel laureate Jennifer Doudna. And Jennifer was given the Nobel Prize for her work in developing CRISPR. And so CRISPR is really simply the ability. It's a molecule that essentially has the ability to zero in on a specific target of DNA sequence, and you can cut the sequence to be able to essentially turn off a gene, which it means that it would stop the function of some sort, or you can actually insert a segment of nucleic acid to turn something on or to provide a new function or a new trait of some sort. And the beauty of this is that, yes, it's being huge amounts of money are being pushed into CRISPR technologies for biomedical and new ways to do pharmaceutical. In fact, the very first approval of the first CRISPR-based drug, it's curing sickle cell. This is something that has been incurable and just sort of treating the symptoms for the longest time. It actually now is FDA approved to show that it actually completely has the ability to alleviate those symptoms. So the promise of CRISPR is enormous, but I think I'm here, and the same thing David was saying, I'm here to basically say, look, yes, let's push fully into biomedical tools and technologies, but CRISPR is universal. This is something that it has the ability to modify DNA. DNA is in microorganisms that emit methane. They're in microorganisms that emit nitrous oxide. It's in plants, and those plants can help feed the world. So there's a lot of potential for CRISPR to be able to be unlocked in this area of food, natural lands, trees, as well as climate.
Excellent, thank you. Now, Shara, you're the CEO of C16 Biosciences, and you're where, I guess we'll need a more climate smart phrase, but you're where the rubber meets the road. Talk about what you do and how you're applying these technologies to the world.
Yes. So C16 Biosciences is making high-performance bio-designed ingredients, and we are focused on fats and oils as a specific application of that. So the fats and oils industry is $250 billion today, with projected population growth over the next 25 years. It's projected to grow 4x, nearly $1 trillion industry. So fats are a huge part of what we eat, but also it's in the cabinets of our bathrooms and our laundry shelves. And they're inputs for things like sustainable aviation fuel and biodiesel and industrial lubricants. So huge part of sort of everybody's daily lives. Today, fats and oils come from sort of three sources: animals, petroleum, or plants, vegetable oils. And each one of those has its own sort of climate issues. And so what we do is make those same oils and fats, and our first product is a palm oil alternative, which I'll talk more about later tonight. But we make those oils and fats instead of using large-scale industrial agriculture or animal husbandry or drilling for oil, by using biotechnology. And specifically, we use microbiology to use microorganisms to make these products, which can feed people.
And zoom in for a second. And I know you're going to talk about this at the plenary tonight, but the palm industry, how, like, what is the potential there for replacing, you know, like in Indonesia, for example, like the deforestation and things like that?
Yeah, so I think this will highlight the power of biotechnology to solve lots of climate problems, and I'll talk about it through the lens of what we are doing. Palm oil is wild. It's in 50% of products on supermarket shelves, but the production of palm oil today emits about 2% of global greenhouse gas emissions, which is more than the entire global aviation sector. So this one vegetable oil, the way that we're producing it, emits more than everybody's aggregate footprint from flying around the world to everything. And really, like, this is just because we have limited arable land to grow food. And so what we're doing today is slashing and burning forest, converting it into industrial plantations to make a vegetable oil. I learned about this firsthand in Southeast Asia a few years ago and thought it was pretty insane that we were burning rainforest to make a vegetable oil. And so my co-founders and I asked a really simple question, which is, why do we have to do that? Couldn't we just sort of brew palm oil like beer? And that's essentially what we're doing. And I think what's really cool is it's a lot biotech, but it's also a lot nature. And so what we've been able to do is go out and find microorganisms which naturally they're really good at making things. So we found a yeast which actually naturally produces oil. It naturally produces lipids. So Mother Nature did a whole lot of the hard work for us. And then what we do in our lab is we're able to sort of apply the latest and greatest tools in biotechnology, which include things like just understanding, how does the yeast grow and how do we optimize its conditions for growth? Chemical engineering of processes and sort of genetic engineering of really understanding the genome of the yeast and understanding what genes and metabolic pathways are responsible for making lipids and making them more productive. It's very promising. I think it's definitely still early days, but we've seen it in pharma. We've seen it in curing disease. And I think it's really exciting now as we look to climate to solve emissions reduction. As I mentioned, palm is primarily CO2. We'll talk about methane and others, but also land use. How do we shift away from using precious land to make vegetable oils, use it for something else, and make these vegetable oils on non-arable land in fermented tanks like we make beer.
That's always a big balancing act, is what do we do with all that land? You know, what is the best, highest use for land? So David, when we talk about climate solutions, you know, it's often weighed in the cost to the economy versus the benefit to the economy. Can you talk a little bit about the bioeconomy and how that might play out over the coming decades as it relates to climate solutions and kind of the scale and how you're thinking about what the bioeconomy might look like going forward?
Let me first highlight something that is really important, because the bioeconomy is also a big user of land. And, you know, people that understand what's causing climate change, we know that it's the accumulation of carbon dioxide in the atmosphere from, you know, human activity. And so the solution, of course, is to reduce that down to zero. And we know from recent analyses that we have to reduce emissions down to zero and go negative. What people often don't realize, we also have to do this on the land side. We have to reduce the conversion of natural lands over to ag lands down to zero, and then get to a point where we can, through innovation, be in a place where we can begin converting ag lands back over to natural lands, or to manage lands that are providing different types of products, ecosystem services or carbon drawdown and removal. And so innovation using biotechnology and other things in food production, we have to get to the place that frees up that ability to spare land, as well as, you know, deal with the carbon side. So it's both and. When it comes to the bioeconomy, in 2018, 2019, I think it was 2018, the National Academies of Science published their, you know, pathways to removal, carbon removal, roadmap, research roadmap, and it highlighted the fact that we have to, you know, we haven't done enough in the way of emissions reductions for long enough, that we have to reduce emissions down to zero, and we have to go negative. And the contribution of negative emissions to net emissions is enormous, even before the crossover point. So this means that we have to build an enormous negative emissions industry. This is a kind of new phenomenon in our thinking. So if we go back 20 years, we knew what was causing climate change. We thought we could reduce emissions and meet our obligations, keep global temperatures below 2 degrees of warming. We didn't do enough for long enough that now we need to build this negative emissions industry. So the concept for our bioeconomy, which is essentially, it's a bioenergy bioeconomy. The policies that were put in place 20 years ago to solve, you know, different policy objectives at that time, created you know, an economy where in the United States we produce 16 billion gallons of ethanol. And so the supply chains are optimized for bioenergy production, and that displaces 16 billion gallons of gasoline. It reduces emissions by, you know, 20 to 50%. So it reduces the overall emissions from our fuel sector by about, you know, 2 to 5%. And, you know, that is a reduction. So we have a bioeconomy that's optimized for energy product recovery that gets us some emissions reductions by displacing petroleum. But the concept of that bioeconomy was developed before we realized we need negative emissions. And perhaps we're thinking about the bioeconomy the wrong way. Now that we know we need to build a negative emissions industry that's enormous and is going to rely on technologies like direct air capture and mineralization, all these other things that are energy intense, we may need to think of the bioeconomy not as a bioenergy bioeconomy that displaces petroleum and gives us emissions reductions through displacement of petroleum, but rather a carbon drawdown bioeconomy that is optimized for pulling carbon out of the atmosphere, stabilizing it into, you know, various things, and keeping it out of the atmosphere. And so it becomes a bioeconomy optimized for carbon drawdown that gives us energy reductions by displacing direct air capture and some of these other energy intense things. That is the transition that is likely to happen, and we need to hasten that, because if you run an analysis that looks at, you know, what's the more valuable thing in photosynthesis, is it the energy accumulation piece or the carbon concentrating piece? If there was a neutral market above $40 a ton carbon, the carbon is more valuable in biomass. And so that has huge implications for our bioeconomy.
And thinking about kind of the biotechnology angle on this, what does that look like in terms of creating that drawdown in the bioeconomy?
Well, it's going to kind of change what are the, you know, breeding and engineering strategies for the crops on the front end. Whereas we had been looking at breeding corn and other, feedstock products to accumulate far more starch per acre at a lower cost and greater yield so that we could ferment it into ethanol, we are now going to look at breeding for crops in more diverse geographic locations to just pull carbon out of the atmosphere and to make it amenable to inexpensive stabilization technologies downstream. One of the things that will happen is it will actually diversify the types of crops that will be in this bioeconomy. Right now, they're very homogeneous because it's just corn and soy. They're the most amenable for the downstream processes. But if, and that's because we very, specifically want ethanol and soybean biodiesel as the output. But if the goal is just to get carbon out of the atmosphere and stabilize it in any form, you can now imagine any number of stabilization technologies, and you can identify different regions that are more amenable to different types of crops that are well suited and bred to just pull carbon out of the atmosphere. In some places it might be bamboo, it could be different types of prairie grasses elsewhere, it could be miscanthus, it could be switchgrass, but you don't care. And so it actually kind of opens up the number of crops, and then using the technologies that Brad was talking about, we'll be able to identify the attributes and breed for and engineer the attributes that maximize carbon drawdown, because that's going to become the new driver for the bioeconomy.
Excellent. Brad, so we talk a lot about carbon, but there are other greenhouse gases, and you're working on reducing methane. Can you talk both about that project kind of overall, but also like diving deeper into it, like what does that look like in the lab? What is like, how do you get to a result that has measurable methane reduction?
Yeah, and measurable is the key word here as well. And I think that's, again, CRISPR is a tool that can actually be used to help quantify things, and I think that's really important. So I want to talk about on both sides a little bit. One is the emission reduction side, which I think CRISPR can absolutely help with. The other is actually sort of the circular bioeconomy. So I'll touch on both of these things, because one thing that biology does really well is it scales really well. Look at all of the agricultural lands around the world, but at the same time, it also has the ability to use waste products. What we consider waste products, biology's like, hey, tasty, this is great, well, I'll use this. And so there's a real opportunity there. But if we go back to the emissions side, we have a really large effort. This is based on a publication that two amazing scientists at the IGI, Jennifer Doudna and also Jill Banfield, together co-published something a couple years ago that basically says that you can take CRISPR and you can directly modify microbes that are living in microbial communities called microbiomes. So these are microbiomes that are found in the gut of a cow, for instance, that are huge emitters of methane. And so the prospect is a very real prospect that you can actually sort of create CRISPR cocktails that could be directly given to a cow that wouldn't just sort of temporarily stop or inhibit, the emissions of methane. But we're talking about completely sort of re-engineering the microbiome so that it shifts away from a high methane state to a low or potentially even zero methane state. There's nothing about the microbiome of a cow that says that it has to have these methane generating organisms that are called methanogens. They've evolved to be there from the different food sources, from just sort of the way that cows have been bred over years and years and years. So wouldn't it be great, if you're able to actually target not just the organisms that generate methane, but the whole ecosystem of organisms that support the generation of methane. So now all of a sudden, it's not just one target, there's multiple targets that you could point this amazing scalpel tool called CRISPR at to be able to potentially shut down the generation of methane. And if you can do it early enough in the cow's life, the microbiome is actually still evolving. It's still adaptable. And so we think that early stage life interventions, where almost every cow in the world is handled by a human early in its life, what if you could just sort of apply a CRISPR treatment, boom, then it goes out. It doesn't matter if it's a dairy cow, it doesn't matter if it's a grazing cow. You've now essentially adapted that cow to a low methane or zero methane microbiome. So those are the kinds of things that we think about at IGI. We think about what those ideal solutions might be, and then we work towards it in the laboratory to try to do that. And we work with partners at UC Davis that try to quantify whether the approaches that we have are working, and that's absolutely important. You have to do these experiments in the actual field to be able to do that. Now, the last thing I want to talk about is the concept of a circular bioeconomy, and we'll just use methane as another example. You could substitute in nitrogen. I promise, nitrous oxide. It has a circular process as well, but in nature, methane is a circular process. There are organisms that generate methane, and there are organisms that use methane. It's called a methanotroph, is an organism that actually metabolizes and oxidizes methane. So there's the real possibility that you actually could use nature to generally have a circular bioeconomy. You're generating methane, but you also potentially could use methane. You generate CO2, there are organisms that use CO2. You generate nitrous oxide, there are organisms that use nitrous oxide. So that is what nature does. That is called the carbon cycle, nitrogen cycle. Nature has the ability to be able to do this. And with CRISPR, I think it's going to help scale and help it make it be more controllable and more quantifiable.
Excellent. Shara, continuing on the bioeconomy theme, how do you think about that? How do you think about the bioeconomy and kind of it's at its infancy, at least as relates to biotech now, and the growth and what that means for companies like yours, but also for people who are thinking about this and starting their own companies working on similar things?
Yeah, it's a new industry. I mean, it's been going, but it's been slow, like you said. So it's still a new industry. It's actually so new that we got left out of the IRA and didn't really get any funding from it. But we do have DoD and the White House paying attention, which is really exciting. I think so. One, there are the products that we make and how they make their way into the economy and to the products that we all buy. We are focused on consumer products. Consumer products have actually a massive impact on emissions, and they're something that we all touch and I think all care about. And so when I think about the bioeconomy, there are opportunities to think about better packaging that are made from the bioeconomy, better ingredients, better whole food sources that are made from the bioeconomy. So that's something just that shows up in our lives every day. There's, of course, infrastructure, manufacturing. What does that look like? What most of these technologies involve. So some are sort of agriculture and out in the field. Some are fermentation. So it sort of looks like what global beer production looks like. And then last but not least, there's jobs. And I mean, this is something that comes up quite a bit. A lot of palm oil today is produced 85% of it is produced in Southeast Asia, in Indonesia and Malaysia. And so as we invent a new technology and deploy that technology at scale to produce a palm oil alternative, what happens to those jobs? What I think is, with all green transition, the job transition is a hard and challenging point, and it's never so simple as retrain these people to do this job. But there is potential, and one of the most exciting things about the bioeconomy is it can be deployed anywhere. It can be deployed in any country. It can be deployed on non-arable land, which is a super important point. And we can think about which, a lot of the people that we're talking to, both companies which buy palm oil, but also countries which have to import it, are thinking about this in terms of surety of supply. So Russia's invasion of Ukraine, for example, totally disrupted vegetable oil supply. It's like 80% of the world's sunflower oil comes from that part of the world. Nobody could source sunflower oil anymore. And so they had to really shift. And so you start to realize how delicate these supply chains are. Of course, we saw it with COVID, but we've seen it in other areas too. And so a lot of these companies, but also countries, are thinking about, how do I have more resilience in my supply chain, and how can I build up economies to make things either as a manufacturer, where, back to the circular economy, I make packaged food, I have a waste stream from that production of packaged food, and then I take the waste stream, I use it as feedstock, and I turn it into new ingredients like lipids. And that's something we're working on with some of our food manufacturing partners. So this is actually happening. It's pretty exciting.
So I'm going to turn now to policy. I'm going to ask each of you about this, but David, thinking about kind of how new this space is and how often policymakers are learning and figuring out, about technologies either on the curve of the public or maybe even behind the curve, in terms of creating those policies. What are the things that you anticipate policy-wise needing in the next half decade to a decade for this sector to be successful, but also to be safe and reliable and all the other things that we need from it?
Well, first of all, there does need to be a rethink of the policies that incentivize decision making in how we use biomass resources. That would, begin to shift the thinking about how we construct bioeconomy supply chains and what sorts of things we're optimizing around. So there does need to be a shift in valuing the energy in biomass to valuing the carbon, and that is certainly a policy barrier to kind of better aligning the bioeconomy with our climate challenges. In general, when it comes to biotechnology, we do need a regulatory environment that is nuanced in allowing for things like genetically modified organisms and deployment of genetically modified crops and seeds to be regulated in a way that is safe for the environment and for consumers, but that isn't arbitrarily limited based on kind of broad stroke scare tactics of GMOs and other sorts of things like that. That will require kind of different tracks in terms of approvals for biotechnology that take them into the realm of what are the regulations for biotechnologies used in agricultural applications or in food applications or in bioeconomy applications versus pharmaceutical applications, and allow for the regulations to be able to be promulgated and adaptive to the needs of those different sectors, as opposed to all slow and unable to deploy technologies into the environment that need to be.
Shara, for a company like yours, what are the policies that can help enable your work, and what are the policies that might hinder that?
So some sticks which are being thrown around recently in Europe. There's sort of two big pieces of regulation: the sustainability due diligence requirements and the EU deforestation regulation, both of which were passed within the past sort of 12 to 24 months and are being implemented now. These are both forcing companies to clean up their supply chains and to do it with a level of rigor that has never been enforced in the past. So with palm as an example, because this is what I live and breathe, today companies are allowed to say, oh, our palm oil is certified to be sustainably sourced. There's this third party. They make sure that the plantation did not engage in deforestation. And while that has been well-intentioned, it's been mostly a failure. There's been, of course, corruption, but also just it's really hard to trace all the way back to plantations. The traceability is really, really challenging. And so it's been limited today. So in Europe, we're now seeing mandated through regulation. There are 7 crops, palm and soybean are 2 of them, where you have to demonstrate that they did not engage in deforestation and certification does not pass muster. And so you can solve that through better geolocation, which is great, and or you can solve it through innovation like ours. And so I think those types of sticks are very powerful and they're long overdue. I think we all know, things like palm oil are not fully priced because there's no price on CO2, and so it's not fully priced, not to mention things like child labor and debt bondage. And so to have these types of sticks, which are sort of enforcing higher standards, I think are very good tailwinds. I think the things that will slow the industry down, the other would be funding for infrastructure. This is atoms, not bits. We make real things. It costs money to make real things, and you have to scale them up physically. And finding the right kind of financing with the right cost of capital to build this entire economy is really important. And I think in pharma, we've seen the infrastructure with large pharmaceutical companies and large CDMOs be able to support this. I think our industry still needs it. That's not necessarily policy, but it could be. I think the biggest risk is probably the GMO scare tactics. I don't think it's policy necessarily. I think it's sort of lack of understanding and or protecting interest around general scare tactics.
Brad, what are the policies for you that both can enable or hinder your work?
I think generally the policy landscape's actually pretty favorable. Just even though over the last couple of years, you've seen shifts that are more favorable towards technologies like CRISPR, gene editing technologies. A lot of times you can make a crop that could just have occurred in nature. If inside rice, there might be crossbreeding that occurs or something, and all we're doing is basically using a molecular tool to be able to essentially make those changes genetically that could have already naturally have been made. So in the United States, you see very good regulatory landscape. Places Central and South America, very good regulatory landscape. Even Africa and Asia, countries like India. India has essentially now mimicked the U.S. policy. So I think generally we see really, really strong movement in sort of an accepting level. The one exception is Europe. And that's sort of the elephant in the room. Europe has traditionally regulated CRISPR as a GMO. So there are a lot of companies in the world, like almost all of the companies in the world that are innovating in this space. I've been told by like the CTO of Corteva that they have CRISPR products that are just on the shelf, that are not being deployed, that are not being used, because if the product makes its way to Europe, then they're done. So now, the good news is that I think Europe is starting to come around. I think that there's opportunities for conversations. They've opened the door, especially if CRISPR and gene-edited crops can support sustainability goals, whether that's emission reductions, if it's climate resiliencies, then they will drop that GMO label, and then it would then allow there to be more of a flood of CRISPR-based products. Now, there's also the aspect of consumer acceptance, and I think that's, I know that's not a government policy per se, but I think that the acceptance, a lot of the communities that we talk to, I mean, there are already CRISPR-based foods on the market, especially if they're geared towards things that the consumer wants. If it's a lower emission beef, for instance, if it is a more nutritious vegetable of some sort, I think people are going to say, yes, I want these, and I think that consumers may actually be able to help drive this to be able to sort of have more global acceptance.
So continuing on that topic, Brad, I think something we heard this morning in the opening plenary was, what if we get it right? And what if we do the things we need to do to reduce emissions and solve climate change? I think a lot of what the public thinking around both climate solutions broadly, but also biotech, is those negative kind of connotations of the future. How do you think about the public perception of the work that you're doing, and kind of how you talk about it publicly, kind of the ethical implications of things?
Yeah, well, what I haven't said is that I spent most of my career in the Department of Defense. And so you can't even lift a finger in the biotech area in the Department of Defense without immediately thinking about the ethical and legal and social implications. My last job was at a place called DARPA. We had standing committees that were called ELSI committees, environmental, legal, social implications. And those committees were best informed if you talk to them at the beginning stages of development. So as you're developing a biomanufacturing process for palm oils, or if you're developing a new seed or a treatment for a calf that would reduce methane emissions, talk to those bioethicists, the regulatory aspects, the community aspects, conversation, openness, transparency, These are things that have to be done at the earliest stage. And so when Jennifer founded our institute, she immediately started what we now call a public impact team. So we have a director of public impact. We have a diversity, equity, and inclusion officer. We have a community outreach individual. We have someone who specializes in the regulatory aspects. A member of our scientific advisory board is a bioethicist. We consider all aspects of this, and I think we're very unique in the fact that we're a scientific institute that can do that. I think it takes someone like Jennifer and her standing, but we feel compelled to be able to include all of those considerations as we move forward with our new technologies.
And thinking about the products that you're going to be making in terms of how you communicate that, people will be making choices in the supermarket, looking at the back of products. How do you think about that in terms of the public perception, the ethics, all of it?
On the one hand, it's simplicity, and on the other hand, it's sort of like don't dumb it down, like treat people like adults. So we have launched our sort of first product through, we called it the Palmless platform for sustainable ingredients. And I think on the one hand, that's the simplicity point, which is consumers, myself included, we're so overwhelmed. What's good? What's bad? What am I supposed to do? How do I interpret this? And so just being really clear about who we are, what we do, and why you care. You don't have to remember our brand name. It's Palmless. It's really, really simple. And I think that is an important communication tool. On the other hand, don't treat people like idiots. So simplicity can sometimes be treated as dumbing it down. I think it's very important not to do that, especially given the history of GMO backlash. And so talking about the role of innovation and not sort of shying away from it, but focusing on benefits is something that we do all the time.
David, how do you think about this in terms of the public communication, the ethics surrounding this?
I agree with the statement about highlighting the benefits, that we have tools through science that have been developed to help us solve resource challenges and to kind of meet the moment that we are in addressing climate change. And it is important that we make science-based decisions in the regulatory environment. And as Brad was noting that, and you've highlighted as well, the United States is fairly good at that, and that we have, our bureaucracy can be slow at times, but it does, have mechanisms to make science-based decisions and to not allow the decisions that are going to affect whether technologies can be deployed and products can be brought to market to be influenced by kind of irrational concerns, or to even slow things down significantly like the Europeans have done. They may be coming around now, but are we going to see all of Greenland at the beach before we get there? We need to be kind of separating the public education piece of the technologies from the public policy piece, and working on both of those things in parallel, but certainly not slowing the necessary progress and solutions coming to market arbitrarily.
David, funding in this space, what exists, I guess, from the federal government, from the climate bills that we've seen passed in the last couple of years? Is there funding in the IRA and the bipartisan infrastructure bill for this, or is this something that needs to be taken up in the future?
As was mentioned earlier, there isn't very concise line items that would directly support some of the identified pathways in the bioeconomy that are going to displace things like palm and other things like that directly. But there are opportunities in the IRA that begin to change. As I was mentioning earlier, one of the policy things we have to do is change the incentive structure on how we use biomass. And what will come from that is a different focus on biotechnology to make that transition. And in the IRA, there are new, pricing mechanisms for carbon removal that would allow us to conceive of bioeconomy supply chains that are more profitable, that are optimized for carbon drawdown than in bioenergy or bioproduct synthesis. And so actually, being so we need to see some entrepreneurs come and try to take advantage of those incentives to actually demonstrate that this is a new area. And with that will come innovation on the tech side, bringing along additional private sector dollars and philanthropy dollars to develop the technologies to take advantage of those incentives. So they're there, they're not direct, they're not spelled out as clearly or as functionally as they need to be, but that's government, and we got to take what we have. The IRA is a really profound piece of legislation that we need to get really creative about how we use it to the fullest extent.
Sure. Are you seeing the investment needed, VCs, private capital that is going to need to be there over the coming years?
Short answer, no. This is such a missed opportunity. No. I sort of alluded to fats and oils earlier. This is going to be almost $1 trillion industry by 2050, and there's been about $100 million in VC funding. It's nothing, and it's really, this is radicalizing how we make food. It's reimagining food production systems in a way that has to happen. And it's a huge opportunity to make money. And so I think it is a really, really missed opportunity. And as I mentioned earlier, I think, one of the biggest challenges is the scale up piece of it. So there's everything that needs to happen in the lab, and ask Brad, it's very hard. It's actually, engineering biology is not the same as engineering code. Yes, we can control it a lot, but biology is unpredictable. It is hard.
Get used to failure.
Get used to failure, but at this and confusion, what happened? It's a black box. But at the same time, we've made so much progress, and we actually have done incredible things, making all sorts of products that we didn't think were possible and economically viable ways. So there's the technology piece, which needs more funding, but the scale-up piece is the piece that I'm sort of the most concerned about. And I think a lot of other areas in climate have more sophisticated project finance and infrastructure type financing. And for this economy, we've got to figure out how to support scale-up of the infrastructure and production in a way that's capital efficient, and that is completely missing today. It's a huge opportunity.
And are you seeing that as there's the funding for the research to get to the product, but then there's also the funding for the manufacturing and kind of the factory, if you will, that everything's created in, is two separate buckets that both don't exist?
Yeah, I think there's a little more for the science. We still need a lot more. And again, we need a lot more because it's a huge opportunity. And then the second bit, the part for the scale up, is almost non-existent. I am optimistic because as I mentioned earlier, I do think this becomes a national security issue for a lot of governments and countries. And so I am actually optimistic that there are countries that will step up and have been stepping up to start to fund this. But I think private players should really, really be stepping in as well.
And I'll just chip in, having been in the Silicon Valley kind of world for the last few years. We've started, just at the IGI, we've started 21 different companies. 95% of those companies are in biomedical. It is a tried and true investment. Venture capital is very comfortable with it. They know what the milestones are. They know what the metrics are. They know that, this company's turned into a unicorn. This company's turned into a unicorn. There's just a comfort level with private capital for biomedical. But there's so much opportunity in this other space. There's not as much of a tried and true highway to success. So there's a lot of just trepidation. There's a lot of just sitting on the sidelines, waiting to sort of see, is philanthropy going to come in and de-risk some of this? Is government going to come in and de-risk some of this? And private capital is just kind of waiting. And it's tough. There are companies that are out there, but most of them are sort of in this, is it going to succeed? Is it not going to succeed? There aren't huge success stories like there are in biopharma that make investors say, yes, I want a piece of that.
So the other piece of the formula for this industry growing is the people. Brett, are you seeing students and grad students, kind of coming into the space? Are there enough people coming into the space to start all of these companies and to do all the research that's needed?
So I was giving a talk at the U.S. Naval Academy a few months ago, and there were 300 undergraduates. A lot of them were midshipmen and women, but others were from different universities around the country. And I gave my standard talk. I talk about biomedical applications of CRISPR, then I switch and I say, oh, you might not have known that there are actually climate applications of CRISPR as well. And I go through all of the different areas that you could potentially could make an impact. I probably had 40 students come up to me afterwards. I had 3 concentric circles of students coming up. And half of them, oh, Brad, I didn't realize I was going to go be a doctor. I was going to go into biomedical research. Johns Hopkins bioengineers come up to me saying, I was thinking about medical devices and going into biomedical. I didn't realize that molecular biology tools and things like CRISPR could be used for sustainability and for climate. So part of it's just messaging and getting the message out there that there is opportunity, that there are ways for new tools to really make an impact beyond just biomedical. And so that's part of why I'm so passionate about this.
It seems like an opportunity to be in Silicon Valley in like the early 70s as the personal computer was being developed.
Yeah, absolutely.
So I've got one more question for each of you, and then I want to open it up to questions from the audience. So thinking ahead to 2050, what does the world look like if you're successful in your work? David, do you want to start?
I think the food system is going to look a lot differently if we're successful. Begin to think about how we engineer controlled environment farms and vertical farms to actually give us the ability to spare more land and meet the growing population requirements of Earth, the increasing affluence of the average inhabitant of Earth that was going to require more resources. And so, as I was saying, through innovation, we're going to need technologies that spare land, and I think that's one of them. Biotechnology is going to be necessary to kind of breed and engineer new types of crops that are optimized for growing in a controlled environment as opposed to inland. Our bioeconomy will shift, and the value of the products from it will be different. I think one of the main products of the industrial bioeconomies, rather than being bioenergy, will be carbon drawdown and ecosystem services. How those will be priced and how that'll be financed will be interesting to see how that evolves. But in terms of raw efficiency for what we need to use bioeconomies for, it's going to be in those places and in markets that don't exist now, carbon drawdown, ecosystem services. And again, biotechnology is going to be necessary to help engineer and breed those types of crops. And then finally, I think there'll be a lot of, to the stuff that Brad was talking about, there'll be a lot of these, unique opportunities where we identify very specific challenges, whether that's methane from cattle production or nitrous oxide from the ag sector, where you target very specific challenges with biotechnologies and we solve those, and we don't even know what those specific technologies will look like, but I have faith that we will solve them. So those are, I think, the big trends that I see from likely by 2050.
Excellent. Shara?
Well, I'm a founder, so always be selling. So everyone in this room will have touched a palmless product today. And on the other hand, something we didn't talk a lot about, but a lot of this land, which has been already sort of primary forest converted to industrial plantations, there's an opportunity to reforest a lot of that. And so I think, in addition to having palmless products out everywhere, touching everyone, the way the planet looks will be very different. And a lot of that land around the equator could be reforested, rewilded, and converted back to biodiversity hotspots that they were. And I'm very excited about that future.
Brad?
I think I'm going to keep it simple, and again, without spoiling my Spark talk tomorrow a little bit, I think a stretch goal for 2050 could be a net zero farm.
Excellent.
Just plain and simple, net zero
Yeah.
farm.
So, what questions do we have from the audience? I've got one back there and then one over here. And please introduce yourself.
Hello, can y'all hear me?
Oh.
No?
Yeah. Give it 1 second.
No?
Right here.
Hi, okay. Hi, my name's Keeling McNamee. I'm a PR strategist with Redwood Climate Communications. So something that I think a lot about and I would love to hear y'all expand on are what are some of the messages that we can, distill to consumers to not only promote trust in these type of products where they're made in a lab or they're somehow not natural, and what are also some tactics we can use to kind of dispel any disinformation that people have heard throughout their entire lives about how not natural products are bad for you.
You want to start with that one?
Yeah, I'll start. Data is so important, and I think, unfortunately, we have to hold ourselves to a higher standard than anybody else. But I think as a group of scientists, I think that's natural. So we're selling in the beauty and personal care industry today, for example. And so we go through very rigorous safety testing, stability testing, but also claims testing. And so going back to the focus on benefits, we do talk about sustainability. I think there's an open question on do consumers care about sustainability? Will they buy things based on sustainability? And what we've found is that it's often a draw where it will get people interested in what we're doing, but the reason they actually buy the product is because it benefits them. And so again, that all just comes down to data. And so I think what we've done is held ourselves to a very high standard of data for safety, stability, higher than what other ingredients in personal care go through, and running clinical testing on benefits. And what's been very cool is, we set out to make a palm oil alternative. It turns out our yeast did that and then some. It made these other components, antioxidants and provitamins, which can do very cool things for skin health that make you look younger and more buoyant skin and all the things that people buy skincare products for. So I sort of take it back to benefits and heavy data. Maybe the second question,
Yeah.
one of you has a
I'll say ditto to everything that you just said. The second thing I want to emphasize is just that the regulatory and safety mechanisms are already in place. So emphasize that we're not doing anything that's outside of the norm of whatever has already been sort of approved. And if you go through the proper channels, the safety, the clinical, the field trials, all of that, just emphasize the fact that there are already mechanisms in place, number one. And I think the second thing is sort of a higher level, more philosophical statement, which is, look, if we still wanted to be eating corn on the cob that was this big, then we should do that. And the things that we put in our bodies now are vastly different genetically than what it was thousands of years ago. It just is. And we've been using sort of human selection for a very, very long time. We now have tools that are actually much more precise and much more targeted, that do not leave any foreign DNA. There's no really, this is something that we are now doing in a much more accurate and much more precise way. So for me, it's just emphasizing that humans have been doing this for millennia. And now we just have tools that are actually probably safer, have been proven to be safer and more precise.
Maybe just one other comment on that. The oil that we make is actually natural. The yeast naturally produces it, just like the plant naturally produces oil. We grow it via fermentation, just like we grow cheese and beer and wine and bread via fermentation. There's actually nothing synthetic about it. The palm oil that you get from a plantation is probably more synthetic because they throw so much fertilizer on it. That's an interesting point. Whether that's worth sort of digging into in sort of consumer communications is another point, and it's much catchier to say lab-grown palm oil. But our product is actually natural and probably more natural than what you get from industrial agriculture today.
David,
I'm glad she mentioned that was the only thing I was going to add, but you already said it. I was like, the framing of like, oh, are these natural? Like, no, they are natural. That's the pushback. Like, these are natural products. The fats and oils that these microorganisms synthesize are naturally occurring. And yeah, that's the pushback. They're actually better. They're natural and they're better.
A question right here in the middle.
Oh, that was Mary. Mary had one.
You. Hi, Mary Maxon from Schmidt Sciences. And somebody who's been working on bioeconomy policy for 20 years. I'm so happy to hear this panel. Thank you so much for doing this. And I was also extremely delighted to see the executive order from the Biden administration that says biomanufacturing is what we need for a national security position and for U.S. competitiveness. We invented biotechnology in California in the 1970s, and Cher, I think you're exactly right. Countries are lapping us on the investments for infrastructure. You're exactly right. I am not so optimistic about the regulatory scenario. David alluded to nuance and timeliness and all of these things that are needed. I'm wondering, for things that are, no offense to CRISPR, broadening out a little bit, intrageneric, not just cisgenic, what's going to be the solution to this? Do we need a new one regulatory agency with brand new statutes? Is that what's needed now?
Mary, I think our government needs you back in it. I mean, you know this better than anybody, having worked at the White House and done these things. You know how the government always is set up like another interagency working group or something. But it may need an executive order level addendum to what the Biden administration announced. That if this is a national security thing, we want to highlight this. They may need to pull together some high-level people with, that are the political level, that have decision-making authority, and say, we need to put together a team very quickly to identify what are the barriers to really realizing this vision on the regulatory side, and prioritize, a multi-agency rulemaking that is targeted at that. And so don't even push it down into the normal regulatory offices at FDA or EPA or USDA. Actually elevate it, make it a presidential priority with politicals leading it, and push all of the agencies that would normally be dragging their feet if it was just their show to actually compete to be the most team playery in a interagency process. That's the way to accelerate that, I think.
Anything else to add to that question? All right, we have time for one more question right here in the front.
There you are. Thank you. You mentioned that Europe does not permit GMO, genetically modified organism, products, and we do. What are we missing that they know about? Or are they running out of fear? Or what is the story here?
I really appreciate that you put it that, like, we're missing something. And I'm going to say, nope, we're not. This is just one where the Europeans are not on the level.
And David, it's not even we. It's like 90% of the world. Like, this is not a U.S. versus Europe thing. This is like the rest of the world. Look at Central America. Look at South America. Look at Asia. I mean, India has 1.4 billion people. So I think Europe is the outlier here, unfortunately.
Maybe just one sort of quick comment on that. I think it highlights this broader tension between sustainability and what we've historically defined as natural. And you've got these examples of like, oh, if everybody wants, free range chickens and eggs, like, that requires a hell of a lot of land, and that doesn't actually work for global populations. And so historical definitions of natural and sustainable have had this tension. I would sort of root it in something similar to that, and it goes back to the first question, which is sort of like, we need to update our definition of what natural is, and then maybe that tension doesn't exist anymore.
Yeah.
Well, join me in thanking our panelists.